Hello guys, welcome to my YouTube channel, The Matrix Tutor. Okay, so this will be my first video. Okay, so let me just give a brief introductory of myself. Okay, so I basically will be teaching topics and subjects based on the Malaysian Matriculation syllabus. And for today, I'm starting off with Maths Chapter 1, Numerical Solutions. And for this video, I will be focusing on 1.1, which is on numerical solutions of equations. Okay guys, so I would like to stress also another thing is that whenever we learn something, a topic or a subject, a particular topic, before learning it, we should ask ourselves, what are we actually learning and why are we learning it? How is it going to be applicable to our daily lives? And so I've narrowed it down here, which is on the purpose of us learning 1.1, which is to determine the location of roots in an interval. Okay, so this is how it is. Okay, so now we've known how to find roots for just say linear and quadratic function. Okay, let's just say a linear function is x plus 1 here. Okay, so now we know how to find the roots for this, right? Okay, how we make y as 0, then we can get x. For just say quadratic function, y equals to x squared plus 4. Okay, so for this function we also know how to find the roots. We can use completing the square method and so on. What if we've been given a more complex function? Let's just say a reciprocal function, y equals to 2 over x plus 4 or something like that. So we haven't learned it yet, how to find the root of it. So for this, we'll first learn how to find the interval of the roots. So instead of not knowing where the roots are located at all, we narrow it down to a certain interval. So now we know the location of the roots is located in this interval of such and such. Okay, so for finding the roots of an interval, we have two methods over here. First is the graphical method, and then we have the change of sign method. Okay, first I will be focusing on the graphical method. Okay, so how do we do this is that if just say given a function fx, let's just say, so if given a function fx, we first divide that function, the singular function, into two different functions. Let's just say gx and also hx. Okay, so once we've got two different functions, we plot both of those functions on a graph and on the same axis. Okay, and so next, once we've plotted it, we will notice that there will be a point of intersections. Okay, so this is what it indicates. First we find how many intersections are there. If just say there's one, or just say there's two intersections. Okay, two intersections indicates that there are two roots for our main function. Our main function is fx. So if there's two intersections, that means there's two roots for our main function, which is fx. And then next we find the intersection is located between what x coordinate. Okay, let's just say the intersection is located between x equals to 1 and x equals to 3. That means the root of our main function, of our fx function, is located in the interval of 1 and 3. Okay, so basically that's the concept of it. Okay, first find the root, find the intersection, determine how many intersections there are, and then see the intersections are located between which x coordinates. The x coordinates determine the interval of the roots of our main functions. Okay, so that's just some briefing about graphical method. So for further understanding, now let's look at one example. Okay, so as here you can see, I've named it as example 1. Okay, so normally questions will be like this. Okay, so by using graphical method, they ask us to find the interval of root of equation x cubed minus 4x minus x equals to 0 in the form of AB. Okay, so if we have understand it, so this is our main function. Main function meaning this is our fx. Okay, so next what we do is, since we've got our fx already, as I've said, we divide it into two different functions, gx and hx. Okay, does it need to be gx and hx necessarily? Okay, it can be anything, ax, zx, according to your preference. Okay, so this is how we do it. Okay, so we write back the function. Okay, so we can divide it into two different equations. How? Just like this. Okay, okay, so I'll just transfer this whole thing towards this side. Okay, that's it. And then we get this x cubed, and then on the other side we've got 4x plus 6, and this is what I mean. We label this as gx and then this as hx. Okay, so once we've got both of our equations, now the next step is us plotting it on a graph on the same axis. Okay, so this is what we get when we plot the graph. Okay, so now as you can see here, there's only one intersection over here. That means there is only one intersection for our main equation, okay, which is this. There's only one intersection, meaning there's only one root for our equation. Okay, so next we look at the intersection is located between what x coordinate. So as here I've narrowed it down, so we can see that it's located between x equals 2 and x equals to 3. That means our interval of the root is 2, 3. That's it. Okay, so this is actually just the basic concept of graphical method. Okay, so once we've gotten this, so we've gotten our interval and we know there's only one root for our main function. Next, what we have to do is we have to make a conclusion for it. Okay, in order to get marks for the last point, we have to make sure that we make a conclusion, a proper conclusion. Okay, so this is how we make the conclusion. Okay, the x coordinates for intersection between y equals to 4x plus 6. Okay, this is our hx, and y equals to x cubed, this is our gx, lie between x equals to x equals to 3. Thus the root of equation, this is our main function, fx, lie in the interval of 2 and 3. Okay guys, so that's it for graphical method. Okay guys, so for the next step we'll focus on exercises. Okay, so for the first question I'm focusing on a graphical method. Okay, so first let's read the question itself. By sketching the graphs y equals to x squared and y equals to x cubed minus 1 on a single diagram, find the interval in the form AB where the root of the equation is located. Okay, so now this is our main function, our fx function. Okay, and lucky enough for us, they've already separated it into two different equations, two different functions, which is this and also this. So we can also say in other words that this is our gx, this is our hx. Okay, so once we've got this ready, we've reached this point, the next step is to plot a graph. Okay, so before plotting a graph, okay, some of you may do this table, some of you may not do this table, okay, because we need to know certain x values and y values before plotting the graphs, right? Okay, we cannot just simply plot it. Okay, so for this we find for the quadratic graph we find the y-intercept of it. So of course when we find y-intercept, we have to make sure our x is a 0. So when we substitute the value, we get y is equal to 0 as well. So okay, now for the cubic graph, we substitute x is equal to 0, we get y is negative 1. So from this, we know that this graph has undergone translation. Okay, translation. Okay, that means it has lowered by 1 unit. Okay, so this is just information about the graph. Okay, so now let's plot the graph. Okay, So now please, okay, just a humble request from me. So if you're plotting it, please make sure you use ruler on a paper. So I know mine is messy because I've just plotted using free hands. Okay, please use ruler. Use ruler for the axis. Definitely for the graph, you need to use freehand. Okay. Okay. So for this, since we've plotted it already, okay. So now we can see from here that there's only one intersection. That means there's only one root for main function or main curve of the graph. Okay. Okay, so now here there's a bit trouble for us. Why? Because we need to find, we know that one value, the first value of the interval, okay, of our interval is 0, okay, because it's more than 0. You can see definitely more than 0, but we don't know what is the next value of it. Okay, so for this there's actually a trick for this. Okay, so now after plotting the graph, okay, we know that okay, that this part of the cubic function is much more steeper than the quadratic function. Okay, so we need to use try and error method, and where when we substitute an x value, the y value for the cubic graph is much more higher than the y value for the quadratic graph. Okay, so now let's just say we use x value as 1. Okay, we use x value as 1, our y value is also 1. Okay, so we do the same thing for cubic graph. Say here's 1, but then here will be 0. Okay, so now from this we know that the cubic graph is the y value for cubic graph is lesser than the quadratic graph, so this cannot be the other value of our interval. It should be higher. Okay, so now let's use 2 instead. So use 2, y will be 4. Use 2 here, y will be 7. Okay, so we can know that, okay, from this we know that the y value is higher for cubic than quadratic, and so we can assume that this part is equals to 2. Okay, so we just interpolate it. Okay, so for quadratic one, this side will be 4, and then for cubic, if you go up here, this side will be 7. Okay, so that's it. So now we know that our interval is 0, 2. Okay, that's it. Okay, so once we've got it already, we just make a conclusion. Okay, a conclusion. Okay, so the conclusion will be like this: the x coordinate of intersection between, okay, now we state both of those different functions. Okay, the separated one, which is y equals to x squared and y equals to x cubed minus 1, lie between x equals to 0 and x equals to 2. Thus the interval of roots of equation. Okay, now we state the main function, which is fx. Is in interval of 1, 2. Okay guys, so that's it. That's how we make a simple conclusion for this, and that's how we solve, and that's how we go about these types of question for graphical method. Okay, so I hope you understand it.